This table 5.2b2-1 as seen here is an illustration of different so-called present values corresponding to a future value. Similarly, we can have different future values corresponding to a present value depending on how many periods forward we go. So this table actually just gives numbers. So if we have a future value or starting point today of 161.051, then at the rate of 10%, the present value would have been 146.41 one period ago, or 133.1 2 periods ago, or 121 3 periods ago. So the concept of present value and future value really is a relative concept. Present value means the value today, right now. So if we were standing here 5 periods ago, we would have a present value of 100, and 5 periods later, that value would become 161.051. So we'll drill down those concepts using the formula in Excel. And these are the calculations of those concepts. So 100 is equal to 161.05 divided by 1 plus 10% to the power 5. So because we are traveling back 5 periods, or 4 periods in this case, and 3 periods and 2 periods and so on. And these are different future values. And so if we pick up this future value of 121, then at time t equals 2, then if you go 1 period prior, it is going to be 121 divided by 1.1 to the power 1, because 0.1 is the rate of interest. So that becomes 110. Similarly, we could also go back 2 periods prior, and so this should be a power of 2. 121 divided by 1.1 to the power of 2 is 100. So now let's see all of this in this table here. So first of all, we know that 100 times 1 plus, we want to do it ourselves, sorry. So 1 plus, let's just say $AE$1, just for the sake of simplicity, to the power of 5. That'll give us 100 times, right, so there is no rate here. Now we just put rate here. So rate, and that is a rate. Actually, we can use a much more fancy symbol, Alt-NU, and then we can find that key here, right there, insert and close. So we can have a very fancy looking arrow right there. So that's a 5 period later future value, 4 period later future value, 3 period later future value, 2 period later future value, and 1 period later future value, and the value today really. So there is no periods here. So if we travel back 1 period, so equals this divided by parenthesis 1 plus $AE$1. Actually, let's make it $AE$1. We want to fix everything. To the power of 1. And so how can we automate this? We could automate this very straightforward. It's very straightforward. So we just do Control X, and then here 1, 2, 3, 4, 5. And so it is pretty straightforward. Just say $AE$3, and it's going to remain $AE$3. So we go 1 period prior, $AE$3, 1 period prior, $AE$3, 1 period prior. And so we're just going back 1 period prior. Now we could go back 1 period prior from 0 to -1. That's why this concept of present value and future value is really relative. And so we really don't want to go before 100. Let's assume our starting value was 100. Now we can do this Control R. So we're going back 2 periods prior. No, we're not. So we have to say it is $84. And so Control D, Control D, Control D, Control D. Now let's check. So yep. So the rate is AE1. The future value is AD4. And because we fixed the column, it doesn't move to the right as we copy the formula to the right in Excel. And then to the power of AF$3, which is the periods, and this one shifts to the right as we copy the formula to the right, but does not shift to the right as we copy the formula down using Control D key in Excel. So 110, 100, and then 121, 110, 100, and Control R, Control D, Control R. So this is basically how we calculated the present value n periods prior, and the n essentially is right here. So n, Alt NU, please insert this beautiful looking arrow for us and close. So this is n, and n is 1, 2, 3, 4. So this is n periods prior, the value of this money, where n is actually given here. Okay, so just very quickly, it is exactly what we see in this table. So 161, 146, and these are decreasing to 100, all of them, because 100 was our starting value. Now we can repeat this process using 5, 4, 3. No, we can actually use this with the formula. So it goes this minus 1, Control D, Control D, Control D, Control D. And then we can use this using the, first of all, let's just keep these numbers. So the future value numbers are given to us. Now we can actually use the PV function. And to use a PV function, $AE, $1, number of periods. So how many periods do you want to go back? That'll be AE, $3, because we want this to shift to the right but not to below, comma, payment is 0. There are no intermediate payments. The future value is AD, $11. Now we want, $AD, $11. We want the 11 to become 12, 13, 14, but AD to remain where it is with respect to the periods. So this will be giving us the same answer, 146. Let's just make it minus $80, $11, because we don't like negative answers. So then Control R, Control R, Control R, Control R, and then copy that. Why do we waste our time? Just do Control V, just do Control V, just do Control V, and Control V. And that's exactly how we solve this table 5.2b, which is given here. Essentially, how do we find out the corresponding present values corresponding to a certain future value n periods prior? Thank you for listening.